Great to be with everybody once again. This is a more of a scientific kind of talk about the long-term immunity with COVID-19. If you want to jump to the point of this whole thing is there is long-term, most likely long-term immunity with COVID-19 infection, just like every other viral infection we have, just like all the vaccines we give people. This coronavirus, which is not novel, so to speak, in that 15% of all head colds are caused by coronavirus. It's not necessarily the way it works immunologically is not a new thing. We have experience with this, and immunity lasts. So that's the gist. Let me talk about some of the basic science now, really briefly. And this will be a brief one because I don't want to get too deep into it. There will be an attached article for those who want to dive into the science a little bit more. But the basic idea is when we get infection, we have to involve part of our innate immune system that talks with our acquired immune system. So that's the part of when people talk about T cells or natural killer cells or dendritic cells. It's the part of our immune system that's just waiting to respond mainly to viruses and cancer cells, foreign objects, yeast. When that part of the immune system gets turned on by a viral infection, it has to communicate with your adaptive immune system or your acquired immune system that creates antibodies, which is what we're all talking about. So there's a handoff that happens there and your body makes antibodies. Now with certain infections or certain vaccines, the antibodies will last for years and years and years. Like with shingles, for example, you get chickenpox, you have antibodies your whole entire life. Part of the reason for that is the virus never leaves your body. If you get chickenpox, you get mono, the virus stays in your body for the rest of your life. And there are lots of viruses like that. Certain vaccines, like a polio vaccine, for example, you have a little bit of aluminum in there. The adjuvant activates your immune system, and you maintain these antibodies for a long, long time. However, with certain infections, and we're seeing this with the COVID-19 SARS-CoV-2 virus, that people who don't have severe infection, what will happen is the antibodies will clear after several months. And what we're seeing is with severe infection, the antibodies linger longer. So if you're hospitalized, you'll have antibodies for a longer time. If you get a mild asymptomatic infection or didn't even know about it, your antibodies might clear very quickly. The IgG antibody, which is the main memory antibody we talk about, has a half-life of 28 days, meaning if your immune system is not reactivated or restimulated in 3 half-lives or 3 months, 95% of those antibodies will be gone. So after 4 half-lives or 4 months, the average person won't have antibodies unless these B memory cells and T memory cells are reactivated and told to make antibodies once again. So a lot of our information actually comes from the SARS or the SARS-CoV-1. It's not called CoV-1, but SARS-CoV, which was the original SARS. 17 years after the 2003 outbreak, people are still having antibodies. And some interesting things in this article did show there's a lot of cross-reactivity between that virus and the new one. But what's actually quite interesting is that people who had no history of SARS, CoV-2 or SARS-1 were actually having neutralizing antibodies to the infection 17 years later. So there's a group of people who evidently were exposed to the original SARS who had no symptoms but actually had antibodies 17 years later. And these people, they saw T cells are still active against different parts of the virus. And one thing that's interesting is like there's a lot of similarity between the parts of the virus and the common human coronaviruses, which is maybe one of the reasons why we're seeing cross-reactivity in people in blood bank samples of people who have not had this infection before, historically we know of, but already have neutralizing antibodies to this infection. Also the fact that it can be spread, some of these coronaviruses can be spread between dogs, cats, bats, and rodents. I mean, how many people have cats and dogs? You know, that was one of the concerns about this initially on, but maybe with the common cold and the common coronaviruses, we have this human-animal interaction that actually keeps our immune systems kind of primed. We're also starting to learn about the pre-existing T-cell immunity and the general population being important for this. You know, we're not having a second peak in Italy right now or in New York suggesting that herd immunity is probably less than 70%. Why would that be? Maybe from these pre-existing neutralizing antibodies. So that's really interesting, but I think the gist is that regardless, it appears that immunity is long-term, and there are some people that probably already have immunity from previous coronavirus infections or have neutralizing antibodies from previous coronavirus infections. So the more we learn, the more we realize that this is we can deal with this, we can cope with this. We're developing new treatment regimens, and as we learn more about the SARS-CoV-2, we're learning that it's not quite as what we expected back in March, which is good. This is all good. So I will continue to put these updates out there. Y'all stay safe, be well. If this information is helpful, please share and spread it. And I hope you all take care and have and stay healthy.